Hello, everybody. Thank you to Rally for hosting and to Scala and Lexi for inviting me. So the subject tonight is compiler plugins. I hope to make this interesting or relevant to kind of two different groups of people. In the first half of the talk, I'll be talking about what compiler plugins even are, what compiler plugins can do, which ones are popular. So the whole first half will be from just a Scala user perspective. And then in the second half of the talk, I'll change gears and talk about how compiler plugins are actually created, and I'll show you a sample plugin. I should say something about timing maybe. Originally, the first time I gave this talk, it was 30 minutes with no questions. Last time I gave it, people had tons of questions, and we ended up going for 90, which was maybe a kind of long. But it's fine. If you have questions, please feel free to ask them. I'm more than happy to have this be interactive. I'm the only speaker tonight, so we've got plenty of time. I've been programming in Scala full-time since 2008. I joined the Scala team at Lightbend in 2015, moved here to San Francisco 2 years ago. The reason that I selected this particular topic to do a talk about is that I've written several compiler plugins while working at Lightbend. One of them is called Sculpt, and that's open source now. I put the repo URL up there. If you're curious about it, I have a separate talk about it called Tools for Taming Tangled Code. Video of that is online. It's basically a plugin that analyzes the structure of your code. So not dependencies in the sense of external libraries that you depend on, but dependencies within the code, like from class to class or from source file to source file. If you're in an architect role or doing a lot of refactoring, then Sculpt is something that could help you. So that was my first compiler plugin. The second compiler plugin I wrote is called Fortify SCA for Scala. So that's a commercial product from Lightbend that we did in partnership with Micro Focus, who fortifies their product. It analyzes source code and tries to find security vulnerabilities, like security mistakes in source code. They support tons of programming languages. There's more than 20. And so my role and Lightbend's role was to add Scala to the list of supported languages. And we did that by writing a compiler plugin. So this is an example of a compiler plugin that's an alternate back end to the compiler. It translates Scala into an intermediate language that Micro Focus invented, and then they do their scanning on that. So those were my first two plugins, and then the third one I wrote came about because I'm the primary maintainer of the Scala community build, which is like a big meta build of lots of Scala open source projects that we compile together in order to test changes to Scala itself, as well as to help the ecosystem make sure that their libraries interoperate. So I wanted to write a blog post about the community build. I wanted to know how many lines of code were in it. So I wrote a little plugin called CLOC, and that was surprisingly easy. And it turned out to be only 45 lines of code, so 41 lines of Scala, 4 lines of XML. That's kind of a minimal example of how easy it can be to write a compiler plugin. So that's kind of where I got the idea for the talk, and that's the code that I'll show you later on. One of two example plugins that I'll show. Okay, so part one of this talk is what are plugins, which ones are popular, and how do I use them as a Scala programmer. I should start by just defining my terms briefly. I mean, this question will get answered in more fully as the talk progresses. But a Scala compiler plugin is an extension to the Scala compiler that allows you to alter its behavior without having to change the compiler itself. So it's an API that you write to, and then users can use your alterations to the compiler without having to use a totally different compiler. As we'll see, the variety of things that you can actually do with a plugin is pretty wide. I did a kind of survey to try and find out what open source plugins were out there and which ones were widely used. So you never really have good data on usage. I used GitHub stars, which is of course an imperfect metric, but I would say that the results I got that way, kind of informally matched my own impressions from what I've seen people using, what's out there. I won't explain what every one of these plugins does, obviously, but on the next slide, I'll sort them into some categories to give you an idea of the space of things that are popular. But right away, you'll notice a few things at the top of this list that are really important and that lots of people are using. So I especially want to call attention to Zinc. I put a star next to this one because I'm cheating a little by including it. It's not technically a compiler plugin, but that's purely for historical reasons. It should be, it ought to be. We'd only have to change a few lines of code. So it's sort of morally a compiler plugin. Zinc is the part of SBT that does incremental compilation. And it's separate from SBT because other build tools like Maven and Gradle also use it in order to so you don't have to recompile your whole source code, every time you just change one file. Scala.js and Scala Native are, well-known non-JVM backends for Scala. And somewhat farther down the list here, but definitely rising, is Scalafix. I've put a star next to that one as well because it's actually not a compiler plugin itself, but most of a great deal of the functionality in it is coming from a compiler plugin called Scala Meta, which is a little farther up the list. Scala Meta is a plugin that's the basis for the current and next generation of Scala tooling. So it sort of extracts syntactic and semantic information from Scala code and makes it available to tool authors. So I think that means that over the next few years, this list it may actually shrink, right? Because we'll see that some of these plugins kind of predate Scala Meta and might be better implemented on top of Scala Meta if they were starting today. Okay, before I go on, I want to, you've had a while now to sort of look at this list. Is anyone using a compiler plugin that you know of that I missed? No, okay, all right, good. Um, previous times I've given this talk, I've had to add a few, and I actually had to remove one. The author was there, and he's like, no, that's actually not a compiler plugin. It's like, oh, sorry. Hopefully the rest are accurate. OK, so all these plugins, what do they do? What's possible with these things? I've tried to separate them into some big categories that are separated by the divider lines, and then even further subcategorize. So the top group, the top 3 bullets, are plugins that actually change the language, that add things to the language itself, make writing new kinds of code possible. A compiler plugin can extend the syntax of Scala. Kind projector, which is, I think, in almost universal use among people who do pure functional programming in Scala, adds better syntax for type lambdas. The other syntactic extensions that I found are more experimental. I'm not sure they're as widely used, but they're sort of experiments with improvements to what kind of for comprehensions you can write. Semantic extensions actually change the not just provide a different surface for writing something that is otherwise already possible more verbosely. With semantic extensions, these are actually enabling semantics that weren't possible before. Scala continuations adds delimited continuations, and two tails adds mutual tail recursion. Finally, Macro Paradise is a compiler plugin. So you may be familiar with macros in Scala, or at least have heard of them. So macros and compiler plugins are definitely in the same space here. What Macro Paradise is it's like advanced extensions to Scala macros that that didn't make it into the macros that are built into Scala. So macros of all kinds are experimental in Scala, but there's some Macro Paradise ones are like a separate module that are especially experimental. So that's the top category, extending Scala itself. The second category is tooling. So these are plugins that don't change what code you would write, but just inspect and help you with the code you're already writing. The biggest category is linters. ScalaFix, which I already mentioned, fits into that category. It does not only linting, but also rewriting, but it's a linter as well. And the others on this list are all linters of various kinds. Some of them are general linters. I think wart remover is probably the most widely used. And then the others are do more targeted kinds of linting. Fortify, as I mentioned, is like security linting. Sculpt and acyclic help you with linting program structure, and so forth. Other kinds of tooling include plugins that improve errors and warnings coming out of the compiler, help you do documentation or internationalization. I already explained Zinc. That's kind of a category unto itself. Wasn't sure where else to put it. And then the final category is alternate backends. Scala.js, of course, compiles to JavaScript, and Scala native compiles Scala to LLVM, which can then be further compiled by the standard LLVM backends to native code, either for for iOS or for command line tools and so forth. So hopefully this gives you an idea of the space of things that are possible with these plugins. In order to actually use a compiler plugin, the easiest experience you can have with this, and also a very common one, is that compiler plugin authors will make their plugin easier to use by packaging it within an SBT plugin. And so then adding it to your build just requires this one line, add SBT plugin, and then you specify the Maven coordinates to the jar for the plugin the usual SBT way. That makes it easier to add, and then also an SBT plugin that wraps a compiler plugin may provide extra settings and tasks for configuring or for interacting with the plugin. So you may have this in your build and not realize that there's a compiler plugin behind it. If the compiler plugin doesn't have an SBT wrapper, then adding it to your build looks like this. There's another convenience method called add compiler plugin. Again, you take the Maven coordinates, and then you typically specify this cross-version patch thing. So that's mysterious looking. It's maybe worth mentioning because a useful thing to know about compiler plugins, they usually depend on Scala compiler internals. Scala compiler internals can change even in Scala minor versions. So we try not to change things around too much because it's disruptive for plugin authors. But we don't have the same hard compatibility guarantees on the compiler that we do on the standard library. So compiler plugins should be published according to the specific Scala minor version that it's intended to work with. And that's what crossversion.patch gives you. It's common for a compiler plugin to take configuration options. And so this $P for plugin is the standard way that plugins accept those options. So it's -P, the name of the plugin, and then the name of the option equals and the value. And then, of course, a plugin can define as many of those and with whatever meaning that they want. If add compiler plugin didn't exist, or if you're not using SBT, then you won't have access to it. Then you may need to know the fully manual way for enabling a plugin. And I've actually given it an SBT syntax just because that's what I'm most familiar with. But every build tool has its own syntax for adding a dependency and for specifying a compiler option. It works with command line Scala C as well. So this is all that add compiler plugin is doing. It's really a very thin wrapper for this. The jar for the compiler plugin needs to be on the compiler's class path. And we see this extra thing with configurations and this obscure Maven syntax for that. What that does is it ensures that the compiler plugin is only on your class path at compile time, right? You don't want to have it end up being a dependency for your users at runtime. And that's how you tell the build tool to do that. If you're curious what compiler plugins might already exist in your build, there's a flag to Scala C X plugin list that will just dump a list of which ones are enabled. It's also possible to just look at your list of dependencies in SBT and see which ones have that magic plugin default compile string on them. And that's an example with an actual project of how to get a list like that. I guess before I move on, I'll just pause and ask if there's any questions about anything that I've shown so far. This is kind of the easy part. Okay, another slide of advice for you as a prospective compiler plugin user. If you're thinking about using a plugin, these are questions that you should consider. And the one I've put first is the one that I think is most important, because it's just people should do this and just don't. So check whether it affects your build times. You can, and you know, the concern on this is I don't know. The more popular the plugin, the likelier that the author has kind of checked that it doesn't slow down compile times too much. But lesser used plugins, it's more likely not to have been checked. So I would recommend measuring that. Scala, in general, has a reputation for slow compile times, and certainly a lot of that reputation is deserved, and it's true of vanilla Scala. But you know, at Lightbend, we are often working with customers who you know, have slow build times and want help doing something about that. And it's incredible, actually, how often it turns out that it's coming from the slow compile times are because of either compiler plugins or macros. It's surprisingly rare that it's just the vanilla Scala that's taking so long. If you add a plugin to your build, you should ask whether the plugin supports all of Scala, and there's a whole spectrum of answers on this to whether it's 100% or whether this is a really serious concern. And some of this advice really overlaps between compiler plugins and macros. A plugin or a macro is especially likely to you know, have unpleasant surprises about what subset of Scala it supports if it's actually rearranging code. So something like the Scala continuations plugin, which does a continuation passing style transform on your code, writing a plugin or macro that does that it's really hard to get right. It's hard to get it right even for 90% of Scala code, let alone 100%. So do be careful with that. On a more positive note, the category of plugins that run that are alternate backends, like Scala.js and Scala Native and Fortify, those plugins almost all the time support like literally 100% of Scala, or like for Scala.js, it's like 99%. There's like these really obscure edge cases around, behavior of numerics, for example, where the semantics can be a little different. But basically, the later in the compilation pipeline that a plugin runs, later in the compilation process, all of the diversity of the Scala language, all of these features that exist have been eliminated. By the time you get to the end of the compilation pipeline, your Scala code has been transformed into something that closely resembles Java. I mean, not even Java, current Java, resembles like Java 1, Java 1.1, and also is only a short distance from Java bytecode. So it sometimes surprises people that Scala.js and Scala Native support the full language, but that was something that just sort of pleasantly fell out of the inherent structure of the compiler. You should check if there are binary compatibility concerns. That's usually not the case with a compiler plugin, but something to check on. You should be concerned about tooling support. If I use this plugin, am I going to have lots of red squiggles in IntelliJ because it doesn't know about this change to the language that the plugin makes? This is very common with macros as well. JetBrains does offer an API that lets macro authors and plugin authors extend IntelliJ to understand these language extensions, but it's relatively rare that people actually do the work of using that API to add support. It's also possible to confuse not just an IDE, but also other kinds of tooling like ScalaFix or linters and what have you. You should also be asking yourself, is this going to, how's this going to fly with my team, right? I mean, at my company, how does this affect compatibility with people? This is especially a concern for anything that makes some sort of alteration to the language. Is at that point, you're no longer using vanilla Scala, you're sort of working with a fork of the language. And that's a pretty serious liability for a team to take on. Maybe it's worth it, something to think about. Okay, any further questions? Anyone want to ask the first question about the stuff so far? Yes.
How frequently do you have plugins that conflict, or is there kind of like precedence, or do they interfere with other plugins, or?
Yeah, great question. So the question is it common for plugins to conflict with each other? What happens if I'm using lots of them? I would have to say, in my experience, it's surprisingly rare that there are conflicts. I can't even think of a single common, well-known conflict that people run into. Is there anything else to say about that? It's certainly possible, but I just haven't seen it be a concern in practice. As well, why that might be, I think will maybe become a little clearer once I start talking about the internals, like how plugins, what the API looks like. Because there are enough restrictions on plugins that are sort of designed to keep them out of each other's hair. Any other questions on part one? Okay.
Are they all typically written in Scala?
Yeah, good question. Question is, are the compiler plugins written in Scala? Yes, I think they all are. So I don't know of a counterexample. The API, I'm not actually sure if it would be possible to write a plugin in a different JVM language. I would have to really go over the API and look and see whether there's anything in it that is Scala specific. As we'll see in the sample plugin, there's a sort of nesting. We have the plugin which has a component which has a phase. And boy, I would really have to study it to see whether there's something that would where you would get stuck writing in Java or something else. But as far as I know, this is something that everyone uses Scala itself for. The Scala compiler itself is 100% Scala. There's the Scala standard library is also, almost 100% Scala. There's a few sort of fragments that are in Java. Okay. Any other questions? Okay. Okay. So suppose you want to actually make one of these things. What does that look like? I'll continue with more cautions for scaring you away about whether you really want to do this. As I mentioned, Scala Meta is a major alternative that you should consider if you're doing tooling. So you should look at Scala Meta, ask whether it can support what you're trying to do, and definitely go that route instead if you can. Scala Meta these days is not so new. It's been around, 2-3 years. But there's a major piece of it that only fell into place this spring, which is semantic analysis. So if your tooling actually needs code which has been type checked and has the types attached to every node, Scala Meta didn't do that until fairly recently. When I first gave this talk in March, it was like super brand new, and now it's like it's been out for about 6 months and seems quite robust. Our experience with this on ScalaFix has been great. That it's the Scala Meta powered ability to understand typed code seems really solid, and it shouldn't be too surprising that it worked out that way, because they didn't independently write a separate type checker for Scala Meta. It calls into the typer phase of the actual Scala compiler in order to get the information out. So this was like a glue job rather than a building job. If you're interested in extending or altering the Scala language or doing any kind of metaprogramming, certainly your first choices are to do macros if you can, including the expanded set of capabilities that are in Macro Paradise. So macros are less powerful, and I should try to explain briefly, like, what is the difference? A compiler plugin has much more freedom. A compiler plugin can do global analysis of an entire program. It has free reign to arbitrarily inspect and rewrite whole programs as well as parts of programs. Macros are a much more targeted tool. So anytime someone calls a macro, that macro is only free to alter the meaning of that one piece of code that's inside the body of the macro call. With Macro Paradise, you have somewhat more power because Macro Paradise adds something called macro annotations or annotation macros. People seem to say it both ways around. Ordinary macros are def macros, which means that when you use the macro, it syntactically resembles a method call. With an annotation macro, you attach an annotation to a piece of code, which looks the same as any Java or Scala annotation. But then the macro is then free to not only to rewrite the thing that you annotated, but also to introduce new definitions. For example, if you want, like a common use of annotation macros is to do things that you might otherwise accomplish with code generation. Like suppose Scala didn't have case classes, and I wanted to add them to the language. I could do that with an annotation macro. So that involves not only rewriting the definition of the class that I've annotated with this imaginary case annotation, but it also involves introducing a new definition, which is the companion object. So doing something like that is within the power of Macro Paradise. So those are alternatives to consider, and as always in programming, you should choose the least powerful tool that will do the job. If anyone is wondering at this point about Scala 3 and how this might change, I have a slide on that later. It's a question I'll come back to. Okay, so you've decided, you've ignored my cautions and decided to dive in and do this anyway. If you Google Scala compiler plugin, you'll get a page on the Scala site, which you'll see here hasn't been updated since July 2008. So that was the situation when I started preparing this talk. So a side effect of me writing this talk was that I actually went in and updated that. So now on the Scala documentation site, docs.scalalang.org, where there used to be this blank space under metaprogramming, there is now a compiler plugin section. So I took that page from 2008, stuck my name on it and next to Lex's, and brought it up to date. So it may not be perfect now, but certainly everything that I could think of or see to update is now current and accurate again. Okay, leading in now to actually writing the code for your plugin. In order to plan how your plugin is going to work, you need to know kind of what the shape of the API is that you're going to be writing to. So I've contrasted compiler plugins with macros by saying they're much more powerful. They can do anything. That's not entirely true. You don't have, because this is the JVM, you don't have the ability to just arbitrarily reach into any point of the, any class in the compiler and just change anything you want. So you don't have, you don't have the totally arbitrary freedom. You also are not completely free in terms of deciding when your code will run, the code in your plugin. So the power that you do have is to insert a new compiler phase between existing phases. That is basically the one thing that's in the API. Add a phase. You can decide when that phase runs, but it's always going to be a separate phase that's waits for other things to finish, runs, and then is done and hands off control to the rest of compilation. So those are the limitations. However, once your compiler plugin, once your new compiler phase is active, you have complete power. You have access to NSC Global. NSC stands for New Scala Compiler because it was new in like 2004 or something like that. So it's still NSC. Global is an object in that package that basically it's the God object for the compiler. It has access to everything. So from there you can get to everything, and you're free to access and manipulate anything. So to write your plugin, you're going to have to decide when you want your new compiler phase to run. If you run Scala C with this flag -x show phases, it will print a list of the existing compiler phases and then exit. What I've put on this slide is actually not the full list, so you'll see some of the numbers are missing. I shortened it to what I would consider the major phases, like the ones that anyone doing compiler work is most familiar with and most likely to have to deal with. So parsing comes first, of course. And then I've highlighted two phases that are especially important in terms of deciding when you run. Phase number 4 is typer, so that's when type checking happens. You'll need to decide whether it's appropriate for your plugin to run before typer and process untyped trees, or run after and deal with types. The advantage of having types, obviously, is that there's you need types to do many tasks. But it does also increase the difficulty of what you're doing, just because types are added information. It's more complexity, and they're also rather difficult to manipulate. So if you need to, if you're just changing the syntax, manipulating or rewriting untyped trees is really a ton easier than the typed ones. And then I've also highlighted the last phase, which is generate JVM bytecode. So for back-end plugins like Scala.js and Scala Native, those will run usually immediately before the JVM phase, or maybe a little bit sooner before. How much sooner you might want to run, it depends on how high level or low level the language that you're compiling to is. For example, in the Fortify plugin, I was compiling to a language that doesn't have lambdas. I wanted to wait until delambdify had gotten rid of that to make it easier for me. But like in Scala.js, they're compiling to JavaScript. JavaScript has lambdas, and so you want to keep those in the code that's the input to the plugin. I didn't do a full survey of all the plugins, like in what phase that they run after, but I looked at some of the most common and popular ones. The easiest ones are pre-typer. Those can do syntactic transformations, count lines of code. The sample that I'm going to show, that also obviously that doesn't need types, so that we can run right at the top. Linters typically run post-typer. Anything that does errors and warnings also typically runs immediately or almost immediately after typer. That might be a bit surprising in the case of errors and warnings, because it's like, well, what if the error happens later? But it turns out that almost any error that you can make in Scala code is going to come out of typer or earlier. It's actually pretty rare that invalid code is detected later. I think almost everyone who writes Scala actually kind of has a intuition for this, because you hit compile, and it's like either you get an error in the first 3 seconds, or the computer's just sitting there, and you're like, yes, okay, my code's right, and it's just like grinding through the process of getting all the way through to bytecode. So that it's just more evidence of that property of when errors happen. I mentioned back-end plugins run pre-JVM. I only found one plugin that runs after bytecode generation, which is S coverage. So S coverage is a tool, I think pretty much the standard tool for measuring code coverage in Scala. It's doing bytecode instrumentation, where it's actually inserting stuff into the bytecode. So that seems to be fairly rare category, but it does exist. Okay, let's actually look now at an example of almost the simplest possible plugin. This is the URL of the repo. If you're interested in taking a look at it afterwards. And if you're going to write a plugin, I would suggest literally copying and pasting this repo. Just borrow the whole thing and then rip out the stuff that you don't need. So I won't show everything that's demonstrated here, but there are. I'm basically just going to show you 2 files. But the rest of the stuff in the repo actually is useful in terms of illustrating build and testing. So the important files here are in the resources directory. You need to write some XML, but only 4 lines. So that you just need to tell the compiler what the name of your plugin is and the main class where the code lives. Putting this in source main resources, SBT will automatically add that to the jar in the right place so that the compiler will find it. So that's, we've spent 4 lines of our 45-line budget. And now in source main Scala is the actual Scala code. Is this, well, I was going to say, is that font size large enough? But that bonk was the browser telling me that's as big as it gets. So I hope you can see this. I mentioned that everything in the compiler is in this NSC package under Scala Tools. There's a subpackage plugins, which is where the compiler plugin API lives. So if we let's just get an overview of this entire file. So the stuff at the bottom is auxiliary code. That's just this is just the code for invoking this external tool. I got last time I gave this talk, I got a question of well, why do you need this external tool to count lines of code? So I'll just take a slight tangent on that to say this is this great program that you can apt-get install or brew install that actually knows lots of different programming languages and can filter out comments and blank lines and categorize the code by programming language. So you can run this. You can run this and get a breakdown, the same sort of breakdown you might see on GitHub of what languages you're using and how many source lines of code, so like real lines of code, not counting comments and so forth. So that's just helper stuff. The structure of the plugin itself is nested in 3 parts. So we define our plugin, which extends plugin. Within the plugin, we have a component, which extends plugin component. And then within the component is a phase, which extends standard phase. I don't know the answers to all the questions you might have about this, like why is there this separation? I looked at some plugins and asked some people, and it's like, well, why are these things separate? And it doesn't seem to be, nobody knew. So I think it's certainly the plugins that I've written all just have a single component and a single phase. But you're certainly free to have multiple phases if you want. Multiple components, I have no idea what that's for. Okay, at the plugin level, you're repeating the name of your plugin, which was also in the XML. There's a little description which will show up in X show plugins, or whatever that flag was called. And then you have an init method that where you can do any initialization, but also this is where you do options processing. So we saw that when you're using a plugin, unless you're using it through some sort of SBT plugin facade that provides settings, unless it's happening that way, you pass options with this -p : plugin name thing. This is where those options will actually turn up in your code. So this plugin doesn't take any options. The plugin specifies a list of components. Normally, there's just one of those. The component is where you specify where you run. So runs after and runs before are how you specify that. Here's another place where there are questions about compiler plugins that I can't answer, but that also I know that nobody else could answer either. So I can assure you that it doesn't matter, at least like 99% of the time. So if you look at the compiler plugins documentation, you'll see a reference to a PDF of a long paper that describes this elaborate scheme in the Scala compiler for phase ordering. So you might expect you would just say, I want to run after this phase. But no, there's a constraint solver, and you're writing inputs to this constraint solver, and the solver runs and orders the phases. Don't worry about that. Every plugin I looked at simply used runs after and runs before. You need to specify both of them because the semantics of runs after are runs sometime after. And so I actually screwed this up in the Fortify plugin. I said runs after this phase, and then like 6 months later, I was investigating some bug and realized I was running at a different point than I thought I was. So definitely specify both. And you'll notice that there's a method, if you look at the API, there's a method called runs right after, which sounds very appealing. Don't use that because your plugin will work, but if any 2 plugins use runs right after, then the compiler will say, no, can't do that. So be friendly to other plugins. and don't use runs right after. That was a mistake that I made in this plugin before someone corrected me. Okay, within next level of nesting, let's see, I've been yakking for a while without asking for questions. Yes?
So why are runs after runs before lists?
That is a feature of this elaborate constraint solver that you can say, and I said runs after is runs sometime after, right? So since there's that much freedom, you can say, well, I need to be sometime after these 3 phases. I couldn't find anyone who knows why you would ever want to do that. Yeah. Any other questions about this stuff before I continue?
So I wonder how much changes for Dotty, because I mean, the concept of this microphases, the fusion of that, that's completely new, it's specific to Dotty, right? Is there something similar that will apply here that I can specify which run it, or do you get to the later?
Since you're asking now, let's take a brief detour and talk about Dotty. Because we're actually, I'm going somewhat deep now into details of the Scala 2 API. It's a good time. Yeah, let's talk about Dotty a little bit. Because I have more details to show on the Scala 2 plugin API, but you've already seen the basic idea. You add a compiler phase. So what about Scala 3? Scala 3 also has a compiler plugin API. And if you're curious about it, I don't work on Dotty, so I can't answer like advanced questions about it. But I have looked at these 2 pull requests, one of which actually adds the API. So that landed about 6 months ago on Dotty master. And then there's a separate PR that adds documentation for their API. It's clear from reading the docs that this is very similar. So you're adding a phase, and you can and you specify when it runs, and then you can do anything. One difference that I'm aware of is that Dotty has this concept of research plugins, which Martin is interested in discouraging people from essentially forking the language by having plugins that run early and change the syntax around or change the semantics. So there's like there's a check in the API that will like refuse to run if it thinks that you're in a release build of Dotty instead of a development build of Dotty. Now, obviously this stuff is all open source, so there's really nothing to really stop you from doing this anyway if you want. But at least that sort of extra check is there, at least as a way of communicating to people writing these things like, hey, if you're in this part of the compiler, you should think twice. So, and you asked about microphases. So one of the architectural differences between Scala 2 and Scala 3 is that the Scala 3 compiler Dotty has lots more phases. So I don't remember the number, but like in Scala 2, it's about 25, and they have a ton more than that. So in order to make that work, if you did this in like a naive way, you would make your compiler very slow, right? You'd be doing now I'm doing 100 passes over the trees instead of 25. That would be really slow. So many of those phases are not full phases, but are these little microphases that are basically you express a transformation that you want to do on certain kinds of trees. So the microphases are written to a much more targeted API. And that makes it possible to run all of the microphases together. So it's like the Dotty compiler, it's walking the tree of your code, and when it gets to each node in the tree, it can say, oh, I see that these 9 microphases apply here. Okay, so I was sort of explaining your question to the group, but I don't actually have the answer. I don't recall seeing anything about microphases in that documentation. So I would expect that adding a new microphase ought to be trivial. And if I didn't see it, if I don't remember seeing it there, it's probably because it's easy. And I mean, that's what this whole microphase thing was designed for.
Ideally, one would hope that by writing on a compiler plugin, that I'm not destroying that good performance by inserting another phase, but then the whole pass over the entire tree again. But that the fusion, the blending of those microphases is not be set up by providing a plugin myself.
I would hope and expect so as well. It was clearly designed to be better for this. So, yeah. Oh, any other Scala 3 questions while we're there before I pop the stack?
So, since you mentioned the marking mechanism, I found that really confusing in Scala, the whole generation of different macro systems that with an experimental status. But my understanding is in Scala 3, macros are really out. There's only the inline mechanism. Then there is Scala Meta as a separate project, a separate software for how to do macros, cross codes, and so on. So my understanding is that Scala 3 in the technical sense doesn't have macros any longer, but it was experimentally featured that it's really external to the language now confined to Scala Meta. And so that since Scala Meta is on the other hand very powerful, more powerful than the old black-box macro, so as a user I would sometimes have a hard time to figure out, or the first step would be to figure out, okay, I have this extension, can I do it in Scala itself? Many times I can. Okay, can I do it with Scala Meta? This is that waterfall model, and if I cannot do it in Scala Meta, I will try to do it in the
Yeah, so this is a complicated question about a complicated situation. What is the future of macros in Scala 3, and how does that affect your decisions around what to use? The situation on this is still evolving, as in even just last week. Martin announced, oh, I worked all summer on this thing called transparent methods. That was going to be a replacement for many kinds of macros and metaprogramming. And then just last week, he's like, well, we decided not to do that. The situation is still evolving. It's confusing to everyone. I think that the most, this has people worried, right? I think that the most reassuring thing that I can say about this is that there have been, as the Dotty team tries to do a design for how metaprogramming should work in Scala 3, it's all based on having surveyed users and macro authors and finding out what's out there. They've looked themselves, and there have also been multiple calls for macro authors, library authors, and users to weigh in and say, well, I'm using this macro, this macro, this macro. So the people on the Dotty team have a really clear and solid idea of what people are using macros for in Scala 2, and it's clear from everything that they've said that they intend to support most of it, right? So the area where it's most unclear what will happen is white box macros, which are macros that are allowed to okay, with black box macros, the requirement is that your code type checks before the macro alters it. White box macros are free to alter the code and then say, this all needs to be type checked again because it's different now. It remains genuinely unclear how much of that will still be possible in whatever metaprogramming facilities Scala 3 ends up with. The good news is that most of the macros that people use are either black box macros or are easy to support by other methods. Like shapeless, for example, has a macro in it. The need for that macro is going to disappear entirely in Scala 3. The Dotty team has just hired Miles part-time to work with them on type-level programming and make sure that whole area of metaprogramming is covered by whatever they do. Let's see. I've gotten a bit lost in my own answer here.
So your priority first to try something. So when to try to do something with macros, even it takes a while to read through that stuff and basic examples or when to go directly for the compiler plugin for something I have in mind. Should that be the last option, or is it even simpler to do it as a compiler plugin than to figure out what's the latest with macros and will that go in the future?
I see. Yeah. So I have a definite opinion on this, which is you should not be afraid of macros in Scala 2. You will not make your life easier by choosing compiler plugins instead. And why do I say that? First off. So when you're writing a macro, there's a sort of surface. There's okay. You're writing a compiler plugin. You're writing a macro. Those are two different APIs. But once, and I'm showing the compiler plugin API. But once you get past this sort of first level API of like, here's how I write a plugin, here's how I write a component, here's how I write a phase. Once you're inside the phase, you're just dealing directly with compiler internals. And that's equally true whether you're writing a macro or a compiler plugin. So for any non-trivial macro or for any non-trivial compiler plugin, almost all of the work is in that guts part. And so if you had to change your mind and change a macro into a compiler plugin or vice versa, it's just not that different. There is a hope in Scala 3 to sort of lift most metaprogramming to a higher level where it's not just compiler hacking with a sort of very thin API around it, right? So they're really, the reason that it's taking so long to decide on what the best metaprogramming story is for Scala 3 is that they're working on really hard on doing a good higher level design that keeps you away from compiler guts much more of the time. So on the other hand, if you're writing a macro or a compiler plugin now in Scala 2, you really don't have the choice of waiting for that new mechanism to arrive. So I would say just do your thing. If you're lucky when Scala 3 comes around, your job will be much easier because if these new higher level APIs suit your needs. And if not, and you have to rewrite your macro or rewrite your compiler plugin under Dotty, the other, I guess, good news that I haven't shared yet is that the Dotty compiler internals and the Scala 2 compiler internals, they're not that different. Like if you read the documentation on internals, watch the talks, all of your expertise, almost all of your expertise on Scala 2 internals is going to help you enormously once you're working in Scala 3. It's like the concepts are the same. You've got trees, you've got types, you've got symbols. It's not radically different. So that's a really big topic. And I'm really glad you asked that because it's like in a lot of ways it's like the question about what is the future of that stuff. So I hope I answered well without going on for an hour about it, which someone from the Dotty team I'm sure could easily do. How are we doing on time? It's almost 8 o'clock. So, yeah, let me wrap up the walkthrough here because there's almost nothing left to show. Once you're in your compiler phase, once you're inside the compiler phase, so as I was just saying, at this point, you are now talking directly to compiler internals, and it's really the code is going to look the same regardless of whether you're writing a macro, a compiler plugin, or you're making a pull request to the Scala compiler. The main method that you implement in your phase is just run with no arguments, and you have at it. For a trivial plugin like this, the only, so here I'm calling out to count lines, which is the helper code that actually does the work. Sort of what's interesting here. In the apply method, I'm getting compilation units one at a time. So these are generally source files, but it's a compilation unit is a slightly more abstract concept because the code could be coming from the REPL, for example. So I wait until I have all of my compilation units have been supplied before I actually run. The only sort of tricky thing I hit here is that, and I'll mention it just because I think it's sort of funny, but also you might hit the same thing, which is you need to know that the Scala doc is part of the compiler. When you run Scala doc, it's running the compiler, and so your plugin will run during Scala doc generation unless you take care to disable it. So when I first did this, I was getting line counts that were twice as high as I expected. Until I inserted that check. Okay, so we got to the guts part of this, but there's almost no guts in this one to show. I'll briefly show one other example plugin that does something a little more interesting. So I need to go back to, yeah, okay, so Jason Zog, who's one of my colleagues on the Scala compiler team, has this sample plugin called Boxer, and it's I don't think it was written to be useful. It's another example, although it certainly could be turned into something useful. What it does is it tries to. This is like a linting plugin that tells you if you're using value classes. It finds the places in your code where your value class is getting boxed. So the whole purpose of value classes is to cut down on overhead of boxing. So this is useful. Unfortunately, value classes don't succeed at that 100% of the time. This plugin will tell you when you're failing. So the structure of the plugin is very similar, with a plugin with a component inside it, with a phase inside it. And here we have the actual guts that are talking to compiler internals. So we have a fourth level of nesting here inside our phase. We have a traverser, extends traverser. So traverser is coming. This is like a convenience class that we imported from NSC. I'm actually surprised not to see the import. I think that's, where is the import coming from? Oh yeah, so import global. Jason sort of did a shortcut here and just like imported everything. Yeah, so traverser is coming from global. So the nice thing about this is that it shows actually how easy it is to write a tree walker. So this is something kind of comparable to the microphase stuff in Dotty, not efficiency-wise, but in terms of how easy it is to write the code. So we're here in this example, we're interested in boxing. Anytime boxing happens on a value class, the AST node that represents instantiation is the node called new. So the traverser API runs this traverse method for every subtree of the entire program, and then just lets you pattern match against it. So when you see the kind of node that you're interested in processing, you catch that case, and then you can just let everything else fall through. So we look for those nodes, and then we look at the class that's being instantiated, and we check to see whether something is actually a value class. If it is, we issue a warning. You might be wondering how you might know how to write this, and I have a few slides with advice on that. One thing that I enjoy pointing out about this code is that it uses in this one place it uses this concept that exists in the compiler of time travel. So even though your phase is running at a particular time, and even though the compiler is constantly mutating trees as it runs, it also remembers the states of trees at other phases. So exiting typer is like time travel, saying, well, I'm running later, but I need to go back in time and see how something looked earlier. It's cool, maybe a little scary, but that if you see exiting or entering, it's that time travel thing that's happening. Any questions about the details of this code before I pop back out to more general? We're near the end here, but I do have a few more general slides.
Just a general question about value types. So this is about the class. So when I write the value type, something that extends any value. And it's news to me that there could be situations where there's actually some boxing. It was a naive assumption that
yeah.
said that. I mean, that's the reason why you provided this value type, right? So do you have any? So can I avoid it in the? Or do you have to know when the code the source code not avoid it? Is it rather programming mistake or just some clumsy code that I wrote, or the situations where we cannot avoid it, the boxing must happen there?
the two most typical cases where a value class get boxed, one is when you're using it in a generic context.
Oh, of course, yeah, I see.
Right? And then the other is collections. When you're storing things in collections. So, and just as an aside about value types, so there's an active proposal for replacing value types with something called opaque types. And the reason that proposal exists is exactly because value types didn't achieve this goal of guaranteeing that something is never boxed. Opaque types will give you that guarantee. And I think the hope is that opaque types will, they're already implemented in Dotty. I think that's right. And they're expected to land in Scala 2 in Scala 2.14. Yes? I don't think there's a mechanism for that. Yeah, that's a good question and a funny question. I guess it's a sort of sub question of the one about compatibility. I don't know. I don't know if it blows up or if you just get funny behavior.
So let's say I write something that depends on Cloc. How does it know that it needs Cloc, the Cloc plugin, before it can run the read?
So that is, I'll just revisit an earlier slide. So that happens with add compiler plugin. So I add the jar that contains the compiler plugin as a dependency. In the jar, it knows the name. And so the compiler will look at that XML file in the jar in order to see what the name is. Because it's, you might expect it'll probably be the same as the artifact name, but there's no guarantee there.
So it looks like the name in the XML file is just for humans,
the name in the XML file is actually what determines how the options are passed. So, yeah, normally it'll be the same name in both places, but it's this one that actually matters in terms of using the plugin, and that's coming from the XML file. Okay. I already mentioned that when you publish your plugin, you should publish it by Scala minor version. I've seen some plugin authors just sort of take their chances on this, and sort of usually it works, but there is a possibility of breakage, and I have seen breakage happen. I think in the interest of time, I won't talk about testing, except to just say that there's a few slides on it that I invite you to look at. And for debugging, if print line debugging fails, I want to make this recommendation because I think it's something that people don't necessarily know or don't think to try. The IntelliJ debugger has this marvelous feature where you can use the IntelliJ debugger even if you're not editing or building your code with IntelliJ. So you can attach the IntelliJ debugger to any JVM that was started with some special flags to enable debugger access. So this is this is often how we debug the compiler is we just run the compiler the usual way with these special flags and attach the debugger. You can step through, that works for stepping through plugin code just as well as it works for stepping through the compiler code. It's a trick that's worth learning. Okay, so compiler internals, of course there's no time for an introduction on that. So yes, this is one of those where I'm not going to tell you how to do the hard part. But what I can tell you is I can refer you to learning resources on how to do the hard part. Ideally, this would be a page online, but actually, unfortunately, these learning materials on compiler internals are just scattered in different places. So I've collected the most important links and a few pieces of advice here. For learning the phases, print out the list that you get from XShow phases and study it. Probably the single most powerful ratio of like learning power to size tip I can give you is run some sample programs through the compiler with this phrase, with this flag xprintall. So this will show you, it will pre-print the code that you pass in after every phase. And it'll skip any phase where the code didn't change, which is handy. So that isolates just the things that are changing. So you will see your whatever sample program you put in gradually transform from full-blown Scala to something that looks very much like Java 1.1 and is almost at the bytecode stage. So it's educational and also just cool. I think that you have this easy window into what the compiler is actually doing. In order to get a deeper understanding, the document that everyone doing any kind of compiler hacking, whether it's compiler, plugins, macros, anything, everyone should read symbols, trees, and types. It actually applies to Scala reflection as well. So it's like, this is really the Bible for this whole space. There's a document on the Scala site called the Scala Hacker Guide that walks you through the entire process of making a modification to the Scala compiler. So that's a little more focused on compiler hacking itself in terms of like, here's how the build works, here's how to make your change. But there's a lot of material in that's also relevant to plugin authors and macro authors. I have 2 videos to recommend. One is by Jason Zog, who also wrote that Boxer plugin. This is a pretty long video of more than an hour, but it's super, if you have any sort of affinity for compiler stuff at all, this is like super entertaining, fascinating talk. He takes, it's not a lecture at all, so it's not, it's not like going through concepts. The whole talk takes place in the Scala REPL. There's a feature in the Scala REPL called Power Mode, which I think was added by Paul Phillips some years ago, that enables all sorts of extra compiler hacking goodies. So what he shows you how to do here is how to interactively explore compiler internals, and actually by playing with them, by actually trying things in the REPL. Super cool. Overlapping with this somewhat, and also very good quality, is a talk by Chris Burchell called A Deep Dive into Scala C. The stuff that you'll learn from these learning resources will help you with all of these different kinds of programming besides just compiler plugins. One more talk to recommend, a talk by me called "You Are a Scala Contributor." If you decide to use your newfound compiler hacking knowledge to work on Scala C itself, or also if you're interested in helping out with the Scala Standard Library, Scala modules, the Scala website, this talk is about how to become a contributor to any of those areas of Scala. There's a video online of when I gave this talk in New York earlier this year. I'll also be giving it one more time here in San Francisco in November at Scale by the Bay. We already talked about Scala 3, so we're good there. And that's it. Thank you.